Hello students, welcome to Ant's classes. Let's do sets chapter 6 exercise 6b, page number 80, and we are with question 7. Find the proper subsets of this. Okay, so and what does this say? X is such that x square minus 9x minus 10 is equal to 0. So we are going to take this quadratic equation, solve for x, find the value of x, and then find the proper subsets of that set. So let's take this equation x square minus 9x minus 10. Now we are going to split this middle term. Okay, now how are we going to do that? First we multiply these two, that is x square into 10x. Let's write that x square into minus 10. X square into minus 10 will give us minus 10x square. Now let's look at the middle term. Middle term is minus 9x. Now we have to get two terms in such a way that when you multiply you get minus 10x square, and when you add you get minus 9x. Now what are the numbers that multiply to give us minus 10? The numbers that multiply to give us 10 are 1 into 10, isn't it? 1 into 10 is 10. Now how do we make this minus 10? I can give 1 the minus sign, or I can give 10 the minus sign. Now we have to decide for which one are we going to give the minus sign. Now suppose I give the minus sign for 1, then I will get minus 10. When I multiply, I will get minus 10. And if I put x here and x here, I will get minus 10x square, which is the same as this one. Now with these two terms, will I get minus 9x when I add it up? So that means if I say minus 1x plus 10x, how much will I get? I will get 9x. I will not get minus 9x because the sign is here. It's with 1. So if I put the sign with 10, let's see what we get. So I'm going to remove the sign from here, and instead of the plus sign here, I'm going to put a minus sign. Now 1x minus 10x is minus 9x. Same way, here also I'm going to remove the minus sign from here and put it here. So let's remove the minus sign from here and give this the minus sign, and let's see when we multiply what we get. So 1x into minus 10x is minus 10x square. So when we multiply these two terms, we get minus 10x square. When we add up those two terms, we get minus 9x. That means the two terms are 1x minus 10x when we factorize. Now in the place of minus 9x, we are going to write these two. So let's write that. So x squared, and we're going to write plus 1x minus 10x minus 10 is equal to 0. Now let's get the factors and solve for x. Let's take the first two terms and pick out the common factor from that. So what is common there? In both I can see x. So I'm going to take out 1x. And what is left behind? Here I've taken 1x. That means inside the bracket I need to put one more x. So I have x plus, now I already have x here. So I just have to put plus 1. So I have plus 1. Now remember, I must get this x plus 1 this side also. So now let's take the next two terms. Let's take the next two terms. What do we have? Minus 10x minus 10. What is common to both? Minus 10 is common. So I can keep minus 10 out, and the remaining I can put it in. So what do I have here? From here minus 10x, I've got minus 10 here. I only have to put the x inside. I have to put the x inside. Now I have minus 10 outside here, and here I need to get minus 10 inside. So minus 10 into what will give us minus 10? Into 1, isn't it? Into 1 itself will give us minus 10, and this is equal to 0. Let's make our factors. So x minus 10. So here we can say x minus 10, and the other one which is common already within the brackets, x plus 1, and this is equal to 0. So here we can take just the first factor, that is this x minus 10. So x minus 10 is equal to 0. Now we can get the value of x. X is equal to 0 plus 10. That is x is equal to 10. Now taking the next one, that is x plus 1. So here we can say x plus 1 is equal to 0. Now we can get the value of x. X is equal to 0 minus 1. So that is x is equal to minus 1. So now we can get the elements of the set. So x will be 10 and minus 1. So we have 10 and minus 1. Now we need to get the proper subsets from this. So first let's find the subsets. So the subsets will be, first starting with an empty set, then take 1 at a time, so minus 1, then we have 10, then take both together, so that will be minus 1 and 10. So we have 4 subsets. Now we have to find the proper subsets. The proper subsets are easy to find. It's the same things except the set itself. So this one will not be there, whereas all the others will be there. So we can write that the proper subsets are the empty set, minus 1 and 10. So we have the proper subsets. So this is our final answer. So I hope you understood how to do this. First you have to solve the quadratic equation for x. Find the value of x. So once you find the value of x, those are the elements of the set x. And then you find the subsets and then the proper subsets. Question 8. Given set A is triangles, set B is only isosceles triangles, set C is equilateral triangles. Now we have to state whether the following are true or false. That is, the first one, it says set A is a proper subset of set B. Now what do we have in set A and set B? In set A we have triangles. This can be all kinds of triangles, isosceles triangles, equilateral triangles, we can have right angle triangles, the different kinds of triangles, and set B is only isosceles triangles. Now this statement says set A is a proper subset of set B. Now that is not true because this can contain all triangles, whereas this has only isosceles triangles. So this cannot be a subset of set B. So this statement is false. That means when we say set A is a proper subset of set B, this statement is false. The second one. Now here it says B is a subset of A. So let's see what we have in set B and set A. In set B we have only isosceles triangles. In set A we have triangles. So all isosceles triangles are also triangles, isn't it? So we can say that set B is a subset of set A. So this statement is true. That is, when we say set B is a subset of set A, this statement is true. The next one, here it says set C is a subset of set B. So let's see what set C and set B are. Now set C is equilateral triangles. Equilateral triangles are triangles in which all three sides are of equal length. And set B is isosceles triangles in which two sides are of equal length. So here, if all three sides are of equal length, that means two sides also are of equal length, isn't it? So you can say that set C is a subset of set B. So this statement is true because all equilateral triangles are also isosceles triangles. So this statement is true. The next one here, the fourth one, it says set B is a proper subset of set A. So in set B we have isosceles triangles. In set A we have all triangles including isosceles triangles. That means set B is a proper subset of set A. So we can say set B is a proper subset of set A. The statement is true. Next one. Here it says set C is a proper subset of set A. So what do we have here? Set C is equilateral triangles and set A is triangles. Triangles means it can have all kinds of triangles including equilateral triangles. So you can say that set C is a subset, proper subset of set A. So we can say set C is a proper subset of set A and this statement is true. The next one, here it says set C is a subset of set B, which is a subset of set A. That means we need to take all three sets into consideration. So we have all three sets. So according to this, set C is a subset of set B. That means all equilateral triangles are isosceles triangles according to this, which is true because This has three equal sides, this has two equal sides. So equilateral triangles can also be isosceles triangles. Then it continues by saying that set is a subset of set A. Now isosceles triangles are a subset of A, and A is all kinds of triangles including isosceles triangles. So you can say that this statement is true. That is, set C is a subset of set B, which is a subset of set A. This statement is true. Question 9. Given A is a set of quadrilaterals, B is a set of rectangles, C is a set of squares, and D is a set of rhombuses. State, giving reasons, whether the following statements are true or false. And the first one is this. It says B is a proper subset of C. Now, what are the elements of B? The elements of B are rectangles and the elements of C are squares. Now, are all the elements of B in the set C? Rectangles and squares. Are rectangles also squares? Rectangles are not squares, isn't it? The statement is false. Rectangles cannot be squares. They're both quadrilaterals, they're four-sided figures, but in the rectangle, only the opposite sides are equal. In the square, all four sides are equal. So rectangles are not squares. So this statement is false. Second one, is the set D a proper subset of set B? So let's write down what sets D and B are. D is a set of rhombuses and B is a set of rectangles. Now, are rhombuses rectangles? This statement is false because rhombuses are not rectangles. A rhombus has all sides equal in length, whereas a rectangle has all angles equal and opposite sides equal in length. So this statement that D is a proper subset of B is a false statement. Question 3. The statement says C is a subset of B, which is a subset of A. Let's write down all the elements of sets C, B, and A. C is a set of squares, B is a set of rectangles, and A is a set of quadrilaterals. Now here it says C is a subset of B. That means squares are part of this set rectangles. Now squares can also be rectangles, because they have similar properties as the rectangles. Here also opposite sides are equal. Here also the angles are all 90 degrees. So we can say C is a subset of B. Now is B a subset of A, which is quadrilaterals? Yes, squares and rectangles are quadrilaterals. That means this statement is true. Squares can be rectangles and rectangles are quadrilaterals. So squares are quadrilaterals, rectangles are also quadrilaterals. Now the fourth one says D is a proper subset of A. So let's write down the elements of sets D and A. So set D is rhombuses and set A is quadrilaterals. And all quadrilaterals, all rhombuses are quadrilateral. So this statement is true because a rhombus is a four-sided polygon and it is a quadrilateral. The next question, how do we read this? We say B is a superset of C. So B is the superset of C. So what does this mean? That is, if C is a subset of B, then B is called the superset. Now we normally say C is the subset of B, isn't it? In this case, B becomes the superset. So we say B is the, and we put the superset symbol this way. B is a superset of C. That means all the elements of C should be in B. So it's the other way around here. All the elements of C should be in B. So let's write down the elements of sets B and C. So set B is rectangles and set C is squares. So what does this mean? It means that all the elements of set C are there in set B. Are squares rectangles? We learned that squares can be rectangles because they have the same properties as rectangles. Opposite sides are equal and their angles are 90 degrees. So we can say that B is a superset of C. The statement is true. Squares have the properties of rectangles. Next question. Well, how do we read this? A is a superset of B, which is a superset of D. So let's write down all the elements of A, B, and C. A is quadrilaterals, B is rectangles, and D is rhombuses. Now, what does this mean? A is a superset of B means all the elements of B should be there in A. So, elements of B are rectangles. Are rectangles quadrilaterals? Yes. So, this part is okay. So, that part is true. That is, A is a superset of B because all the elements of B are there in A. Now let's go to the next part. B is a superset of D. That means B is rectangles and D is rhombuses. All the elements of set D, that is rhombuses, should be in set B. Is that true? That is not true. So B cannot be a superset of D. So in this case, B cannot be a superset of D. Whereas D and A, you can see that A is a superset of D. So A is a superset of D. A is a superset of B. It is a superset of D. But B and D, you cannot put it together. B cannot be a superset of D because D is not a subset of B. So this statement is false. Rectangles are quadrilaterals. Okay, rectangles are quadrilaterals. Rhombuses are also quadrilaterals, but rhombuses are not rectangles. So this part is not true. So this statement is false. Question 10. Given universal set is x is such that x belongs to natural numbers and x is greater than or equal to 10 but less than or equal to 35, and a is equal to x belongs to natural numbers, x is lesser than or equal to 16, and b is equal to x is such that is greater than 29. Now we have to find the complement of set A or A dashed and complement of set B or B dash. So first let's find out what the universal set is. Universal set is x is such that x belongs to natural numbers. They're all natural numbers. That means they begin from 1 and this condition should be satisfied. That is, x is greater than or equal to 10. That means we begin from 10 and it's less than or equal to 35. That means we stop at 35. So the universal set is beginning from 10. So that is 10, 11, 12, 13, 14. Now all this up to 35. So this is the universal set. Then let's write the elements of set A. So here what does it say? A is equal to x, which belongs to natural numbers, and x is less than or equal to 16. So what are the elements of set A? Elements of set A will be all natural numbers, and we have to look at the universal set, numbers that are less than or equal to 16. That means starting from 10 up to 16. So let's write all the elements. So that is 10, 11, 12, 13, 14, 15 and 16. Now we have to write the complement of set A. Complement of set A means we leave out all the elements of set A and write the remaining elements which are there in the universal set. So starting from 17, because here we have up to 60. We're going to leave out all these elements and continue from 17. So that will be 17, 18, 19 and so on up to 35. So how do we write this? We say the complement of set A or A dashed is equal to x is such that 17 is less than or equal to x. Now x is greater than or equal to 17 and less than and equal to 35, and we can also say x belongs to natural numbers. Now let's do the same thing with B. Now B, the elements are x is such that x is greater than 29. So look at all the elements in the universal set that are greater than 29. So let's write that. So set B, the elements of set B will be greater than 29 starting from 30, 31, 32, 33, 34 and 35. Remember, we are taking all this from the universal set. So since these are the elements of set B, what will be the elements of the complement of set B? Elements of complement of set B, we have to leave out all these elements and write the remaining elements which are there in the universal set. That means we start from 10 and we go up to 29. So let's write that. So elements here will be 10, 11, 12, 13 and so on up to 29. Why do we stop at 29? Because set B starts from 30. So up to 29. Now this we can write it as x is such that, okay, so B dash is equal to, in the set builder form, x is such that, now we are starting with 10, isn't it? So we can write 10 is less than. So x is greater than or equal to 10 and the last number is 29. So we can say less than or equal to 29. And x belongs to natural numbers. We can add this also. So now we have the complement of set B. X is such that x is greater than or equal to 10, less than or equal to 29. X belongs to natural numbers. Question 11. Given universal set is x belongs to z, that stands for integers, and x is greater than minus 6 but less than or equal to 6. Then set n is such that n is a non-negative number, that means for all positive numbers, and p is x is such that x is a non-positive numbers, that means these are negative numbers. Now we need to find the complement of set n and the complement of set p. So first let's write down what the universal set is. Now the universal set is given to us, belongs to integers and x is greater than minus 6. That means we're going to write all negative numbers that are greater than minus 6 and stop at the positive number 6. So let's write that down. All the elements greater than minus 6 will be minus 5, minus 4, minus 3, minus 2, minus 1, 0. Now we write up to 6. 1, 2, 3, 4, 5 and 6. Now this is the universal set and all our other sets come under this. They all belong to the universal set. So what is set n? Set n is a non-negative number. So from the universal set, look out for all the elements which are not negative. So that will be elements starting from 0 up to 6. So let's write down set n. So set n is a non-negative number. That means all these numbers from the universal set. So let's write 0, 1, 2, 3, 4, 5 and 6. So these are all the elements of set n. Now we are asked to find the complement of set n. Complement of set n means we leave out all these elements and write the remaining elements which are there in the universal set. So what I have underlined belong to set n. We will leave out that and write everything else. So it starts from minus 5. So that will be minus 5, minus 4, minus 3, minus 2 and minus 1. Because here we have zeros, we have to leave out these and write the rest. So we've got n dash. Now p dash is what we have to find out. So first, what is p? So p, the elements are x is such that x is a non-positive number. That means it's a negative number. So from the universal set, we pick out all the negative numbers, leaving out the positive numbers. So let's write all the elements of P. That means all the negative elements from the universal set. So these are all the negative elements. Let's write it down. So that will be minus 5, minus 4, minus 3, minus 2, minus 1. These are all the negative numbers. So when we talk about P dashed or the complement of set B, we have to leave out all these elements and write the remaining elements from the universal set. So that will be all the elements of the universal set, leaving out set P. So let's write out the answer. The complement of set P is 1, 2, 3, 4, 5 and 6. So this is our answer. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.